Welcome back to section 5 of chapter 7. In this section, we are going to be starting to factor trinomials back into their binomial factors. So we're not just seeing what they have in common and pulling that out. We actually have to factor, so we're going to get something plus something times something plus something. However, factoring out what they have in common is always the very first step in factoring. We don't have to worry about that today, but that will be coming back. So our learning targets, we can factor polynomials in the form x squared plus bx plus c. The next section is going to be almost identical, except there's going to be a coefficient, a number, in front of that x squared. So we'll take a look and see what happens then next time. But this time, it's just 1x squared plus bx plus c. So before we get into factoring, let's look to see what actually happens when we multiply these things. So if we have something like x plus 2 times x plus 3, and we multiply, we're going to take the x, and that's going to go to both things, and the 2 is going to go to both things. This gives us x times x, which was x squared, and then x times 3 is plus 3x, and then 2 times x is plus 2x, and then 2 times 3. I'm going to actually write that as 2 times 3 for the moment, because then we combine our like terms, and we get x squared plus 5x plus 2 times 3 was 6. So what actually happened here? What happened is this last number is 2 times 3. We're going to take these two numbers and we multiply to get the constant. And then this middle number, this was 3x plus 2x. So we took, again, these two numbers and we added. So when we go the other direction, we need to find two numbers that multiply to give us that last number, but add to give us the number in the middle. What happens if we look at the kind of our little visual diagram, we can split it up like this. So as another example, let's look at x squared plus 7x plus 12. How would we go about doing this? The first thing, I would not look at the 7 first, because we'd have to think what plus what equals 7. There's a lot of things. When we add them, they could be 7. Let's look more at the 12. What times what could equal 12? We could have 12 times 1, 6 times 2, 4 times 3, or 3 times 4, 2 times 6, and 1 times 12. We don't need to worry about flipping the order on those. We want to know which one, when we add the two numbers, adds to 7. 12 plus 1 is 13, so that's not going to work. 6 plus 2 is 8. That's close, but not going to work. 4 plus 3 is 7. So we're going to use that. And so our binomials will have x, because x times x equals x squared. And then we need a 4 and a 3. So plus 4 plus 3. If we multiplied this out, x times x was x squared. X times 3 is 3x. Plus 4x is 7x. And then 4 times 3 is 12. This idea is what we're doing today. Everything from this point is practice and seeing how like the changes of signs can really affect things. So again, when we do this, we're looking for two numbers that multiply to give us that, and add to give us that. So try a couple. I know we've only seen one example, but give it a shot. We'll go over it in just a minute. But try x squared plus 13x plus 36. Remember, you're looking for two numbers that will multiply to give you 36 and add to give you 13. I'd start by thinking, all right, what multiplies to give 36? And try this one, x squared plus 11x plus 28. Factor that. Remember, the answer is going to be x plus something times x plus something, because x times x will equal x squared. So go ahead and pause me really quick and see if you can factor these. Did you try it? Do you think you got it? You can always check it by multiplying and distributing. So we want to know what times what equals 36. Well, we have 36 times 1. Well, that's going to be 37 when we add them together. That's not even close. Let's see, times 2 would be 18 times 2. When we add those, it'll be 20. It's closer. We have 12 times 3. Well, 12 plus 3 is 15. Closer still. So let's see, 4 times 9 will give us 36. 9 plus 4 is 13. So there we go. Plus 9 plus 4. It does not matter which order you put them in. It could be x plus 4 times x plus 9. Remember, the order of multiplication does not matter. So we have x plus 9 times x plus 4, or x plus 4 times x plus 9. Because 9 times 4 equals 36, 9 plus 4 equals 13. All right, how about the other one? If you didn't try the other one yet, pause me and try it now. Are you ready to move on? All right, so 28. It's 28 times 1, but 28 plus 1 is 29. All right, how about 2? We have 2 and 14. That'll be 16. 3, 3 doesn't divide, but 4 times 7 equals 28, and 4 plus 7 equals 11. So let's see, x squared will have x and x. 4 times 7 is 28. 4 plus 7 equals 11. So we'll have a 4 and a 7. One of the mistakes people make when they aren't paying attention and have no idea what they're doing is they go x squared plus 11 times x plus 28. That don't do that. That's very wrong. We're looking for things that multiplied to give us 28 and added to give us 11. And we got 4 and 7 did that. So we have x plus 4 times x plus 7. So that was if everything was positive. Well, what about when b is negative and c is positive? So in this case, we're going to have something like x squared minus something plus something. Well, now we have to think about signs. What kind of things will multiply to give us a positive number? It's either a positive times a positive or a negative times a negative. They have to be the same sign. If they switch, if we have a positive and a negative, that will multiply to give us a negative number. So a positive and a positive, those add to give us a positive number. A negative and a negative add to give us a negative number. So this is going to be the same thing that we were just doing, except we're going to have x minus something and x minus something. Now they still have to multiply to give us 18 and add to give us 11. So let's see, 18 could be 18 times 1, but that's 19 when we add them. could be 9 times 2, or 6 times 3. 6 times 3, 6 plus 3 is 9, so that's not it. But 9 times 2, 9 plus 2 equals 11. So how about negative 9 minus 2? If we multiply this out, we get x squared minus 2x minus 9x. Negative 2 plus negative 9 is negative 11. And then negative 9 times negative 2 is plus 18. So that factors. So when we have a negative b and a positive c, we're going to have x minus something times x minus something. Before, when it was all positive, we had x plus something, x plus something. So again, the numbers were still multiplying to get that last number and adding to get the number with the x. So try a couple. Try x squared minus 8x plus 15 and x squared minus 13x plus 42. Remember, you'll have x minus something times x minus something. So go ahead and pause me really quick and then come back when you're ready. All right, how do you think you did? For 15, it can be 15 and 1, but that's going to be 16. That's way too big. The other option is 5 times 3. And 5 plus 3 equals 8. So we'll have 5 and 3. But since this is a positive and this is a negative, both of our things have to be negative. So we'll have x minus 5, x minus 3. And again, it could be x minus 3 times x minus 5. That means the same thing. All right, how'd you do on that one? All right, let's go over to this one. So 42, well, if we go 1 times 42, that's good. Add them together, that's 43. 2 times 21, add them, that's 23. 3 times 14, well, that adding is 17. We're getting closer. 3, 4. 4 doesn't go into 42, neither does 5. 6 does. This is 6 times 8. Nope, 6 times 7. Whew, that was a close one. 6 times 7, 6 plus 7 is 13. There we go. So, being that it's a plus 42, they have to be the same sign. Minus 13 means they both have to be negative. So we have x minus 6 times x minus 7. If we multiplied this out, we'd get back to x squared minus 13x plus 42. And remember, it could be x minus 6 times x minus 7, or x minus 7 times x minus 6. We can always switch the order of the two factors. So there we have a negative b and a positive c. So it's x squared minus something x plus something. What if we switch that around? Let's make c negative. So we get something like x squared plus 5x minus 6. What kind of things multiply to give us a negative? A positive number and a negative number. So this is going to give us something like x plus something, x minus something. Now when we have a positive number and a negative number, like let's say 6 is negative 3 times 2. When we add those together, that looks like subtraction, because negative 3 plus 2 is negative 1, right? You owe someone $3, you pay them $2, you still owe them $1. You don't owe them 5, you owe them 1. So it looks like subtraction when we do this. So negative 3 and 2 won't work. 2 and negative 3 also won't work. They'll both give us a 1. It's just one will be plus, one will be minus. So what else times what could equal 6? 6 times 1. When we add those together, when we make one of them negative and add them, Can we get to 5? Yeah, 6 plus negative 1 equals 5. So we'd have x plus 6 and x minus 1, because that 1 is negative. So when we have the x squared and then something x minus a number, we need a positive and a negative. They'll multiply to give us that constant, that's 6, and they will subtract to give us that middle number. Now, the sign here in the middle, the bigger of the two numbers will have that sign. So in this case, it's plus 5. We had a 6 and a 1. The 6 is positive, which means the 1 is negative. If this was x squared minus 5x minus 6, we would have x minus 6 times x plus 1. It just switches where the sign is, and that'll switch the sign of that center thing. So let's try a couple more. Go ahead, give it a shot. Remember, the answers here will have an x plus something and an x minus something. So go ahead, pause me, try it, and then come back when you're ready. All right, let's take a look. 14 could be 14 and 1, but those are going to subtract to give us 13. We're looking for a 5. So 14 could also be 7 times 2. Can we subtract that to get a 5? Yeah, 7 minus 2 is 5. So we're going to have a 7 and a 2. We have x and x. I'm going to put 7 and 2, and then we need to see which one's negative. Remember, this sign goes with the bigger of the two. 7 is bigger, so we have minus and plus 2. If we distribute this, x times x is x squared. Then we have plus 2x minus 7x is minus 5x. And then negative 7 times 2 is negative 14. So we're good to go. How about over here? 16? Well, that could be 16 and 1. That's going to subtract to give us 15, not 6. We could have 8 and 2. 8 and 2 subtract to give us a 6. So we'll go with the 8 times 2. So we'll have an x and an x, an 8 and a 2. This sign goes with the bigger of the two. So that's plus 8 minus 2. So that's x squared minus 2x plus 8x. That's plus 6x. And then 8 times negative 2 is minus 16. So there we go. Notice each of them is an x plus and an x minus. I find it easier, as you see, to put the numbers in. So I had an x and an 8, and an x and a negative 2, and then I figured out which one was positive and which one was negative, based on that middle sign. What if we had two variables in here? So we have x squared plus 10xy plus 24y squared. We're doing the same thing. We're doing the same thing. Remember, we have x squared. What times what equals x squared? That's x times x. Well, what times what equals y squared? Y times y. Now we just have to deal with the numbers. Both the signs are positive, so we'll have plus and plus. Then we need two numbers that multiply to give us 24, that add to give us 10. What times what is 24? You can go through your list, but I'm looking at 6 times 4 is 24, and 6 plus 4 is 10. So we'll have a 6 and a 4, but it's a 6y and a 4y. That's the only difference here if we have the trinomial with two variables. If we multiply this out, x times x is x squared. X times 4y is 4xy. Plus 6xy is 10xy. And then 6y times 4y, 6 times 4 is 24, y squared. Good to go. So the process is identical, except we have y's right there. Generally speaking, as we progress, this is not what the factoring looks like. It's what we were doing with only one variable. However, there are times when we do have two variables like this. So let's give it a try. We have x squared plus 12xy plus 32y squared. So looking for two things that multiply to give us 32, that add to give us 12. Notice the signs here are both positive. And then x squared minus 10xy plus 21y squared. So first, notice that's a minus 10xy plus 21y squared. And then do the same thing. Go ahead, pause me, try these, and then come on back. All right, ready to take a look? So we know that this first one, we're going to have x, and that'll be plus something with a y, and x plus something with a y. We just need to figure out what that is. So what times what equals 32 that adds to be 12? Well, 32 could be 1 times 32, 2 times 18, 16, 2 times 16. Add those 2 and 16 will give us 18. So that's not what we're looking for. 3 won't divide. 4, well, this is 4 times 8, and 4 plus 8. Ooh, there we go. It's 12. So we have x plus 4y, x plus 8y. And that's factored. How about the other one? This is a positive, so the signs are the same. That's a negative, so they're both negative. So we'll have an x minus something with a y, and an x plus something with a y. Nope, minus. They're both minus. I just said they were both minus. Both negative. All right, we need two things that multiply to give us 21 that add to give us 10. 21 is 7 times 3, and 7 plus 3 equals 10. So we'll have x minus 7y, x minus 3y. X times x was x squared. Then we have minus 3xy, minus 7xy, it's minus 10xy. And then negative 7y times negative 3y, negative 7 times negative 3 is plus 21y squared. There we go. And then lastly, what if we had like an application problem, a word problem? So here we have bedroom closet has a whole bunch of these things. We have one big x times x, so that's x squared. We have, so there's one of those. We have 1 times 1s, which is 1. There's 35 of those. And we have 1 times x, which is x, and there's 12 of those. So the first step is to write the equation. Being that we're going to make it as big as possible, that means we're going to have to use all of the possibilities. Like we're going to have to use all of them. We're not going to leave some out, because if we did, it's not as big as possible. So we have 1x squared. We have 12 x's. And we have 35 ones. So we can factor this. It's both additions, so we'll have x plus something, x plus something. What times what is 35? Well, 35, that's 1 times 35, or 5 times 7. 1 times 35 isn't even going to be close, but 5 times 7, 5 plus 7 is 12. So we have x plus 5 and x plus 7. So if we were multiplying it out, we'd either have x plus 7 by x plus 5 high, or the other way around. But that's going to give us a rectangle that is as big as possible. So, factoring. This is the next step in factoring. We saw a few different scenarios that it could be, but it's all just about the same. The biggest key, well, biggest couple keys to being able to factor is one, know your factors. what times what equals these numbers. That makes it super easy. The second one is practice, practice, practice. The more you practice factoring, the easier it gets. In the near future, this is going to be just one small step in a bigger problem. Being able to do it easily and not struggle with it is huge in that success. I know that doesn't come overnight, but it does come with practice. So make sure that you are practicing. So I will see you in class where we will practice. But until then, keep working problems, keep asking questions, and as always, happy mathing.